Interestingly, another question of standard exam, a platinum resistance thermometer has a resistance of 5 ohms at 0 degrees Celsius and 9 ohms at 100 degrees Celsius, full stop. Assuming that resistance changes uniformly with temperature, calculate the resistance of the thermometer when the temperature is 45 degrees Celsius. Option A, 13.9 ohms. Option B, 8.9 ohms. Option C, 3.2 ohms. Option D, 6.8 ohms. And option E, 1.8 ohms. Which of these options is the correct option? We don't know it yet, but the only way for us to find out is to solve this accordingly. Right? So let's go. Okay, so there are things we need to understand. First of all, we write solution, alright? Okay. And then we bring out our data. That's the first thing we need to know. Okay? If we do that, we not see what plays out in the first place. Okay? So let's see how it works. Now we have resistance. Okay? R naught at 0 degrees Celsius. Look at 0 degrees Celsius is this. The resistance of the thermometer, of the platinum resistance thermometer at 0 degrees Celsius is this. So R naught is equal to 5 ohms. Take note. Then at 100 degrees Celsius, the resistance is 9 ohms. So we have R100. So 100 is 9 ohms. Alright? And it goes that way. Then the question says, assuming that resistance changes uniformly with temperature, calculate the resistance of the thermometer when the temperature registers 45 degrees Celsius. So, when the temperature theta is equals to 45 degrees Celsius, what is the resistance of the platinum resistant thermometer at this temperature? So we're looking for this unknown. This is unknown. Okay? So what do? There is a formula for it. Quickly, we just put down theta is equal to R 0 minus R theta over R 100 minus R 0. So look at this. That's the formula to use. If you understand this. So what we need to do is to quickly substitute the various values we have into this. Once we do that, everything will fizzle out and we see the correct answer. So let's go for theta. We have 45 degrees Celsius. Alright, 45 degrees. Then for R naught, we have 5. Can you see that? Good. Minus. Look at the next one is R theta. R theta is the one we're looking for. Sorry, there is 100. Yes, 100, 100%. Yes. Kind of that, yes. So we don't forget. Times 100. Times 100. Good. Alright, so look at this very well. All over this. So let's see. When the resistance is 9 ohm, the temperature is this 100. So at 100 degrees Celsius, the resistance is what? 9 ohms. That is 9. Minus. Okay, we bring down this again. R naught, which is 5. Alright? R naught, which is 5. This is theta. So that is it. Very simple. And we go, we maintain our 45. And then what happens here? It's very simple. We have 100 times 5. Let's go. 100 times 5 is 500. Okay? And then 100 times this is going to be minus 100 R theta. That's it. We are done with the numerator, right? The next thing is we simplify the denominator and we have 9 minus 5 is going to be 4. Very good. That's it. And eventually what happens next? We do simple cross multiplication here, whereby this 4 moves to this point and 1 moves to that point. And we're done. So let's see how it goes. At this point, I'm going to clean off this. Alright? I'll clean off this quickly and see what we're going to get. We still maintain our solution because we are still solving. So, 45 and this becomes 45 times 4, or equal to 500 minus 100 r theta. Okay? 100 r theta. Good. So our intention here is to make r theta the subject. But first of all, let's clear this. 45 times 4, we give 180. Good. And we have 500 minus 100 r theta. Good. We're making progress. Look at it very well. So we don't need this, even though that's the one we're looking for. Let's see. Okay? So what happened is this. We now say 180, okay, comes in, this is 500, right? And we have equals to minus 100 r theta. Good. So what happens here? 180 minus 500, of course, is going to be negative 320. Good. And then minus 100 r theta. Good. Look at it very well. Just look at it very well. Very simple. There is minus sign here, there's also minus sign there. It means that this minus sign, we cancel this minus sign. And we're now left with, we can now divide through using 100 here and then 100 there. Of course, r theta becomes, this will take care of this, good. And we're left with this. So, 320, all right, all over 100. Cancel this, cancel that. This will give us 3.2 ohms. Okay? That's the answer, 3.2 ohms. So let's see. We go through our options again and find out which of the options is most suitable. Option A, 13.9 ohms is not it. Option B is 8.9 ohms at all, not it at all. Option C is 3.2 ohms. Of course, we have 3.2. So the resistance of the platinum resistance thermometer at that certain temperature is 3.2 ohms. So option C remains the best option for this question. That's the correct option for this question. Solved.